Hey guys, Mr. McCullough here, and today we are going to look at inheritance and specifically making subclasses from the bug class in the GridWorld case study. So hopefully you're all set up with a case study. If you're not, uh, feel free to check in with me and we'll set up a time to make sure we got that up and running. It can be a little bit tricky, so no worries if you're not there. Okay, so I have made a thing called a BoxBug runner. Actually, College Board pretty much made it for me. I've added a little new icon, and let's review what it does when it runs. Remember, when we click run, we are basically having time move forward. And with each passage of time, the act method is called on for every actor in this grid world. And so let's look at what the BoxBug is doing. They trace out a box. Okay, specifically, what does that mean? Well, it means that they are moving a particular amount of steps. In this case, it is 1, 2, 3, 4. And then they are turning. Okay, so in the case of this red box, 1, 2, 3, 4, and then turn. And if you watch the turn, you'll see it's actually 2 steps, right? Let me slow it down a little bit. Push it all the way to slow. And 1, and 2. Well, the icon makes it a little tricky to see it, but trust me, it's a 45, and then another 45, getting you to 90 degrees on the turn. Okay? So clearly, these guys have some sort of step length that is defined for them, and they're counting it. And once that count equals their defined step length, then they implement a turn. Okay, 1, 2, 3, 4, turn, just like that. Okay. Let me stop this and let's move over to the code over here. So BoxBug has clearly been defined, and in order to see what a BoxBug or any class does really, you need to have some client program. That is a program that implements and runs object of that type. So I have BoxBug runner, and we see that it just has a main method. In that main method, we create a world, which is something you always need to do in GridWorld. Call it world. And I create 2 BoxBugs. And this parameter here that we call in the constructor, you might guess what it is. It represents the side length, so the number of steps taken before the turn is implemented. And for one that I call Alice, for reasons I don't remember now, we give 4, and for the other one we give 3. And notice I changed Alice's color. That is an option that's available to you. How did I know that? This is a good reminder right here. That if you want to know all of the methods that are available to you, there's 2 places that you can and should go. Part of your homework, and a part that I recognize some students might be likely to ignore, but is super critical, is to look at the appendices, that is the back of your GridWorld case study student manual. And there are 2 appendices. In those appendices, you will find the interface for actor. And remember, actor is like I guess you'd say it's the grandparent class. Everything that you see on the screen is a descendant of actor. And bug is a descendant of actor. So that's kind of like the parent class. And then BoxBug, which is the one that we are making, that we're about to make, is a descendant of bug. So we have multi-generational inheritance going on there, which means that anything defined at the actor level is available to us, and anything defined at the bug level is also available to us. That's really critical. And so in order to see what we are capable of doing with our BoxBug, the first thing that you want to do is to go to the appendix and look at the code that has been defined for those things. Now, they don't concern us with the inner details of the actor class. They just give us the interface, which is fine. That shows us the methods that are available to us. And then they do give us the entirety of the bug class. The bug class you can find in the appendix C1 and C2, and the actor interface you can find in the appendix B3. So please take some time and review that. It will be super useful to you. So what are the parameters for adding something into the world? We call on this world object. We say .add. We need to put in a location, which is fairly intuitive, but if you're looking for more details, again, the appendix will help you out. This represents, I always forget if it's row or column. I think it's actually column first. It's a little non-intuitive. And then row, and then the thing that you want to place there. So we put one BoxBug in at 2.5 and the other one in at 1.1. And then we make sure that the world is shown. And with that code, once we run that, we are good to go, and we have a program that looks like the one that I just demoed for you. Now, one other thing we should realize, let me go ahead. I'm going to take Alice out, just comment out that line of code there. So now when we run it, there should only be one BoxBug, and we know that Bob wants to go a distance of 3 before doing the turn. I'm going to start Bob out. Oh, actually, what we have now will demonstrate that well enough. Let's go ahead and run it. And I'm just going to take things nice and slow. I'm going to move this into the camera range. There we go. Okay, so there's Bob, the box bug. And remember, Bob wants to go 3 steps. That's a step length, and then turn. So what happens? 1 step when Bob cannot. Okay? Obviously, there are walls in this particular grid world. It's bounded. And so what happens when you hit a wall and you can't achieve your goal? Well, we actually saw it in the last run, but now you can see specifically, if you're blocked, you turn. Okay, and there's a method that we can use to identify whether we are blocked or if there's any limitation on our bounds, and we'll take a look at that when we write the code. So there we go. Now Bob is happily moving. With a distance of 3. Okay, what next? Let's write the BoxBug code. Obviously, I already have that written, but I'll write another class called BoxBug2 so we can go through that exercise. Let me shut this down over here. All right, so let's do, I guess this is out of review, but we'll do file new, class. Okay, and we'll call it BoxBug2. And finish. Should be everything we need. BoxBug2. Okay. First thing that we want to do is not reinvent the wheel, right? We don't want to write all the code that's already in bug. So we say BoxBug2 extends bug. And boom, now we've just adopted all the code that's available from the bug class. And why is it already unhappy? Bug cannot be resolved to a type. That's strange. Oh, yes. Don't forget your import statement. That could be a headache. Okay. You'll need to import info.gridworld.actor.bug, and boom, now it knows what a bug is. Okay. What are the new data members that a BoxBug is going to need that a regular bug doesn't? Obviously, what distinguishes a BoxBug from a regular bug is that pattern of moving a specific number of steps and then turning once those steps have been taken. So we need two variables actually. And as good encapsulators, we always want our variables to be private, almost always. Okay, so we'll say private int side length. That's how far the bug likes to go before making the turn. And then we'll have another variable, private int steps, that will dictate how far we have gone. Will indicate how far we have gone, okay? And I'm not going to put the comments in, but that doesn't mean that you should not when you write your code. What comes next? Those should be the data members that we need. So now we will put in our constructor. So we'll say public, and our constructor has the same name as the class itself, BoxBug2. And what do we need? So what defines a BoxBug? I mean, the one thing, obviously the number of steps we want to set to 0, because when a bug is birthed, it hasn't taken any steps yet. But what defines each bug is going to be its side length. So we will have a single parameter, and we'll say int length. Okay, and so let's do side length first. Be consistent. Side length is assign the value of length, and steps is assign the value of 0, and that should do it for the constructor. Okay, here's where looking at the appendix will be super useful. The thing that defines an actor is it has an act method. And if you remember to the demo that we did a few days ago, there's just kind of a dummy method act in the actor class that just like flips the actor back and forth. Okay, not useful. And then bug does something that overrides that. I've actually forgotten what a regular bug does. Sorry. So we're going to override what the bug does when it acts. And so we want the signature for act, which if we look at it, is it's a void method, and it's act, and no parameters are required. It's just saying like, hey, when time passes, okay, so with each step click or each iteration of the run, what do I do? And if you think about it, there's a choice, right? We can either move forward or we can turn, okay? And the things that dictate whether we can move forward, let's do this first. First, let's do the steps, okay? If steps is less than side length, okay, so have we gotten to a required number of steps? Okay, and the other thing, and again, looking at the code here is going to be helpful. If steps are less than side length, then we can move forward, and we also need to be able to move. So there's a method that will dictate if the thing that is in front of us is blocking us, and it's called canMove. And if we can move, then we move, which is another method that is defined for us that we inherit. Okay? And moving just moves us forward one step in the direction that we are facing. Okay, I'm down to a minute here on this video. The other thing that we need to do, of course, is to increment our steps. All right, we just took a step. We need to count that, see if we have yet achieved our goal. Okay. Otherwise, so else, what will we do? We turn once, turn again, and once we made that turn, we need to set steps back to 0. Those are the only methods, and I have 20 seconds. If you want to have a different image for BoxBug, which I recommend, all you need to do is to find a GIF that has the same name as your class and to insert it into the source folder, so the same place as the Java files. See ya.